Okay, I think we're good now. I think we should be live. I am still struggling with the. Yeah. Okay. So I am going to start by doing a recap, mostly for my own benefit, to be honest, because I also don't really have to get or I have to get my head back into it. So, where were we? Let me just do this, which I did last time. So I am going to set the prompt. I'm going to activate. Alright, yes, okay, so I'm going to set the prompt so it's a short prompt. It's a little bit better for everyone because you can see it this way much better. And I have activated the coargs. I am inside the coargs environment and Quanda, and I am inside the coargs directory. So I'm checking the. Let me just actually quickly check that everything looks good. If I go to the YouTube website, yes, this is correct. 3. Okay, great. Alright, so here, let's just quickly check. Everything was committed, so that's good. And we had this file, which I'm just gonna run it again. Okay. Okay. One thing at a time. So why was this data not there? Okay, I see, because this was I was running this, the path was relative, so it has to be, okay, and then, so here I'm just gonna use this magic command. So here I'm using NeoVim, but this is effectively a Jupyter interface. And in Jupyter, so the percentage sign indicates that this is a command for Jupyter, not any actual Python line. So in this case, I am running the matplotlib command, Jupyter command, and telling it to use Qt as a backend, which will open a window, right? And then for all the tools. Okay, again, same issue as before. That's just scan. Did I not do it correctly? Oh yes, there it is. Okay, so this is where we had left off last time. So we had seen that we can use all of these different databases. So actually, these are database / tool combinations, and we can see that all of them have this leftmost side where genes are present only in a very small number of samples, and then most of them have this drop off, except deep ARG or deep ARG that has a drop off at the beginning and then sort of stabilizes, so it has right. Okay, now to that, let's then start looking at this middle ground. So what I had said at the very first time we did this is the extremes don't really help us too much. So the extremes of genes, this leftmost bar, these are genes that show up 0 times or show up 1 or 2 samples. This really doesn't help us. And then on the rightmost side, you have genes that show up in almost all the samples. So we have about 7,000 samples because we restricted ourselves to the human gut, and then we filtered by a minimum number of reads. So the total is about 6,000 something. So the things that appear in almost all the samples, they're also not particularly informative. Therefore, we are going to be looking in the center. Let's do that then. Okay, let's do that. Okay, let's pick one, and I am actually going to pick RGI strict because RGI is nice. We've used it a lot internally. We're somewhat familiar with it, and we've actually. And I'll post it in the chat as well. So we use RGI also. So RGI is from the card. So the card database, the same group that builds card, they built RGI, which is the tool that goes with card, and then they also designed this ontology, the arrow ontology, and we are pretty big fans of the arrow ontology, and we have a tool that works. A tool that basically makes everything else map to the arrow ontology, and actually just gonna post a video which Vedant did about it. Anyway, alright, so we're pretty big fans of RGI on Arrow, and so we are going to be let's look at this. Okay, so let's see. Let's see. Alright, so the tool happens to be RGI strict, so that actually works well. I'm not really sure what I'm doing right now, so I'm just going to start typing. Don't worry about it later. Okay, so df is okay, so df is the abundance. So so we have 7,000 samples by 2,000 genes. Okay, and so for now we are going to be using these gene names. So these come from card, and for now let's pretend these are just some random IDs. We don't know anything about them. We don't even know what a beta-lactamase is, right? And maybe later, and later is almost certainly not going to be today, we will see that actually there's the arrow ontology, or the antibiotic resistance ontology, has a lot of information about these, so we can actually group these into meaningful classes by either the kind of mechanism, the kind of antibiotic they target. So that will probably be really, really relevant later on. But for now, let's just ignore this a little bit. So what I want to do is, so we have here, this is a frequency, and okay, all right, and probably okay, let's see, this is the frequency. Okay, and as I said, let's ignore everything that's between 20 and 80% of samples. Again, we're not or so the number of samples 7,000, and let's do it like this, and okay, let's do it like this. So this is so this way these are, let's just look at this. Yeah, this way these are nice integers, and it's okay, and so this is freq. actually, I really don't know what I'm doing here, so freaky. Does this work? Nope. This does not work. Does this work? Okay, this works like this. No, this is not at all what I wanted. Okay, what I'm gonna do is I'm gonna literally. So okay, so I polars Python select columns. So as I said before, I don't know how to. I don't know how to use. Okay, apparently my internet is a little bit iffy. Let's hope that this sorts itself out. See if OBS is saying. I don't know what to do about it, but the internet is a little bit iffy. Let's see. Okay, hopefully it will sort itself out in a second. Okay, so polar select by column value. Select columns by value. Let's see. Let's do first. Let's just first select the first condition. Just select the ones that are. Oh, okay. What about okay? Okay. Alright, let's go again. Let's start again. Alright, so this is freak. And this. Not sure that was correct or not. Let's do it. Okay, so if I do this, can I do this? Nope. Can I do this? Nope. Okay, and YouTube still complains that. Okay, I don't. yes, I don't know what to do about it. YouTube still complains that has stream quality is poor, but I don't know what to do about it. Alright, let's see. Okay. Let's do polars. Select. Oh, let me try something. I'll be right back. I'm just gonna kill something else that's running on the machine. Okay, I'm back. So I remembered I was running something else on this machine and I went ahead and just killed it. I will restart it later. Right, let's see if select. Okay, this seems reasonable. Filter selected columns based on column aggregate. Okay. Actually, I don't know about this tools compress. Oh, okay. Alright, thank you. I am going to make it slightly bigger. And also for the yeah, I'm just zooming in everything now. I will figure out how to make the text a bit bigger next time. Alright, so compress. Okay, this is what we want to do. Return data elements corresponding to true selectors and okay, frankly this seems too complicated by oh, there's also filter instead of select. Filter. What is the structure? Nope. Okay, so yeah, because filter would work on the rows, and whereas we want to work on the columns. Okay, so filters, column selection. So okay, right. There needs to be a way where I can run an expression on a column and select that column based on that expression. Polars, select column based on expression. Based on value, right? Not just based on an expression, but the column, but on the actual value. So not based on values. No. Okay, yeah, so this seems pretty. Okay, this is pretty good. Yeah, maybe not the most intuitive. Let me make it. Maybe not the most intuitive. Maybe not the most intuitive. It makes a lot more sense if you are at least somewhat familiar with SQL, because it feels very much like an SQL expression where you have then an inner expression, as opposed to the more pandas type of reasoning where you build an intermediate matrix. Right. So okay, but this does what we want, and actually this bit in the middle here, which I'm cutting out now. I'm not even sure what to call them. Let's call them interesting. This is what we want. And now we want to go back to the. We wanted to go back to the full. Yeah, we want to go back to the full matrix and just select the interesting ones. Okay. And now what do we want to do? So let me just see. So here we have 312. Alright, so let's do a 312 by 312 matrix that counts all pairs. So we would have a matrix such that we can close all of these things. We would have a matrix such that the column, well, actually it would be a symmetric matrix with column, but if we go to a position ij, then that means how often do the genes at I and the gene j co-occur in the same metagenome. Right, so how would we do that? Alright, so okay, do we have NumPy here? Yeah, we have NumPy. Okay, so let's construct a okay, so count, this is fine. not at all correct. So let's do let's have the diagonal be okay. I don't think this is at all correct. Okay, so we'll have the diagonal, the count of how often these things occur, and here two number. Let's see this. The access parameter for sum is deprecated. Use data frame sum horizontal. Okay. Okay, let's do one by one. Sum horizontal. Yeah, but it doesn't do the same as before. Is there a sum vertical? Nope. Alright, again. Alright, let's do this. Let's do this again. Okay, since I'm really just starting out with polars now, I think it's a good idea to not just learn whatever this means, the new version right now, as instead of figuring out. Instead of figuring it out later. Okay, like polars. Okay, so alright, so it seems that I was saying axis equals 0, and that's deprecated because I should just say sum with no axis. Okay, now this is this exists. Okay, yeah, scalar, yeah, there's now so many of these libraries in Python. So PyTorch would have scalar, but polars doesn't have scalar. So polars to scalar. If I just do this. Okay. Alright, that's okay, we set the diagonal, which was set the diagonal. Okay, now let's do something a little bit more interesting, which is to set the ij. Let's do, for example, let's just, how do we set the let's do this step by step. So we would want to select I and j, correct. And then, yes, this seems correct. Yes, so this seems, okay. so this is right. Let me just okay. So this is what I think I'm trying to do. All right. So I'm going to be selecting the two genes I'm interested in, named interesting I and interesting J, and then select so select here is the SQL select, so transform so that the value of either column is greater than 0, so this will now be just a boolean, and then I'm going to sum them, and so if I sum them as booleans, so that's we have three possible outcomes, right? So 0, which means neither one of them is true, 1 meaning one is true, the other one is false, or 2 meaning that both are true. So then we count the number of times in which both are true, and that should give us the number of times in which we observe both genes. So okay, so let's see. I don't know what to call this. I'm going to call this a mask. And then okay, and now we have here. Yeah, this is my. Okay, this is apparently taking a while. And okay, so it's always a little bit difficult to understand when things take a while, if it's just a matter of waiting a slightly bit longer, or whether we should do something about it. Okay, there it is. So in this case, let's not do anything about it. Okay. Somehow something happened with the stream again, but now it says it's excellent. I think something restarted here. Okay, in the meanwhile, let's see. Yep. Oh, okay. Alright, so this was so I made a mistake. Right now I am not going to run it again. I am just going to do a little bit of surgery there, and this is the matrix of co-occurrences. And okay, it's actually quite nice. Quite nice. So there's been absolutely no post-processing done here, because we're just taking the gene. So the order of the rows and the columns, which is actually exactly the same, is just the order in which they came, which I think is actually just alphabetical order. So this is just this order here. Interesting. Yeah, it looks alphabetical, but you can see, even though it's alphabetical, and it's alphabetical in this, it's not even alphabetical. It's alphabetical in this ASCII ways, so that the capital letters all come before the lowercase letters. So that capital A through capital Y, and then lowercase a, through lowercase z or y again. Still there is some structure here. So for example, all of these dead genes, they show up together. And so I think this is why we see this structure. You know, we see these blocks here, right? This is okay. All right. So, So what can we do with this? So the first thing we could do is go back to the Stone Age of bioinformatics and look at this as some sort of heat map. Well, which we've done, we've visualized the heat map and now cluster the rows and columns to see the grouping. So, say it's the Stone Age of bioinformatics, but it's still pretty much it's pretty much still valid. Yes, Ascibetical, I like that one. I had never seen it. Yes, so this is about 5,000 samples, but now the rows and columns are the genes. So each row. So this would be that gene, whatever the gene at position 220. Here, whatever the gene at position 234, they co-occur, up, some number of things, some number of samples. So this is why the scale is from. Well, we've cut out the top and the bottom, so the scale actually now goes from 1,400 to 5,500 samples maximum. So all of these data are from the GMGC. So these are, by now it's relatively doesn't look as large as it did when we first did it, but we had 7,000 samples. We can think about updating this. At some point. But for now, I think it's a pretty decent data set to explore. Alright, so okay. Again, I'm really so let's see, SciPy hierarchical clustering. I've done this so many times, and this curly hair common in Scotland. Why is that a recommended search term? Alright, so I've done this many times, and every single time I have to Google how to do it, and partly because the API from SciPy is not the easiest. It's very flexible, but it's not. Actually, I think everything is quite good. It's just that the combination of how the API from SciPy interacts with the API from Matplotlib to do the plotting, it becomes a little bit unintuitive to remember, or maybe I just don't remember it very well. Okay, so side cluster and spatial, yes. Alright, so if I do this, okay, I got something. Oh yeah, I mean it's input Y might be either a 1D condensed distance matrix or a 2D array of observation vectors, which I guess is pretty nice that you have this option, but it's not really. Okay, that's optimal ordering, yes. And returns Z or Z, depending which variation of English you are speaking. This will be either letter Z or the letter Z. The hierarchical cluster encoded as a linkage matrix. Okay. Okay, so optimal lift. I don't know. Flat height, cluster map. Okay, as I said at the very beginning when I started with this project, so if I am going to be streaming to show that there's a significant amount of just Googling how to do things, because I am also trying to learn polars at the same time. That is maybe a little bit more than the usual, but still, like, I've called these functions so many times, and every time I somehow have to remember how to do it all over again. Okay. Does this help? Not at all. Okay, this is not helpful at all. Let's see. Can we do this horizontal? Okay, not bad. Can just okay, let's clear the okay. Not really helpful at all, but okay. Let me do this. Okay, this looks actually kind of nice. Is this true? What is leaves? Let me just check what I'm. Okay, so I was just checking. Okay, so leaves is a permutation of the inputs, and so this should just be a rewording of the input. So this counts just be, and so this should just be the same matrix. This should just be this matrix, but now reordered to make the blocks apparent. Is this true? So if I, for example, column 9 is this, yep, okay, this seems to be working correctly. Alright, so what are we gonna do? Alright, so I'm gonna wrap this up. So we've been writing a bunch of code, and I just started typing onto this file that we had, this explore.py, which was fine as it was, and we made some code, we wrote something, but we also added these lines, for example, there, this line and this line, they don't actually do anything. Here we created a figure, then we cleared it because we had to clear it, but we can, So what I'm gonna do is, I am going to do a, I don't know, what do you call it? Heat map gene counts. Example. Copy everything there. Okay, so I'm gonna So I restored the previous file explore.py because threw everything away, and now here I'm going to do the opposite, which is I am going to only keep the things we want. So the tool we want is strict. So we don't need any of these things, we just need we don't actually use this compress, we use Seaborn, we use LCMA, we use everything here. Okay, now I am going to, so I exited and I am going to run everything again from scratch. Just make sure that we have okay, so this is pretty lazy code because we copied and pasted from one file to the other and then edited. So as things evolve, I expect that we will slowly be cleaning this up, and maybe so some of these things, there will be reused between scripts instead of having each script be its own completely independent thing, but hopefully that will happen more organically, not hopefully, so that's my expectation, is that this will be a little bit of an organic process. So today we are running out of time, but otherwise, for example, these operations, this would probably be very easy to abstract and have some sort of load data kind of mini internal library where this would be abstracted away. Then maybe we can start that in the next one. Okay, maybe one thing we'll do, notes. Some notes. so we can have here some notes for next time. Library. Okay, and so we did this here. These don't need to be uppercase. Normally upper. So this is a pure convention, but normally uppercase is reserved for things that are magic numbers, and these are not really magic numbers. So magic numbers are things that somehow show up in the code with no real explanation of how they got there, except that somehow they are relevant to the so here for example we don't have a magic number, but so we do have a couple of magic numbers. So we have here the 2 million, this is a magic number, and then this human gut is, so it's not a magic number, but it's a magic string, so habitat. So this would be no. Okay, so this is also typical that we start with magic numbers written in the code, and then as as things progress and become a little bit cleaner, they get converted into proper names. So instead of having just the raw number 2 million there, we would have the number, we would have the 2 million as here as a magic number, and then probably next time I will clean this up a little bit and call this the load data function. For example, we could also be a little bit smarter about finding the data directory. Okay, there it is. Oh, okay. Yeah, now this is not what I wanted. It looks not uninteresting, but what I wanted was something more like this. No, share X, not share Y. Okay, this is another one of these things where I always just use it about 17 times per day and forget about whether it's number of rows, number of columns, or number of columns, numbers of rows. As it turns out, it's number of columns, number of rows. So no, here, this way. Okay, all right, so okay, there's something still a little bit off here because this is not the right. Okay, there's still something off with the visualization, but okay, but we are going to wrap up for now. So we can see already that these groupings appear much more obvious in this visualization here. Okay, I actually don't. I don't know how to make this. yeah, we can see that there's some grouping, some structure here. So that's what we will start looking at next time, next week. In the meanwhile, I will, well, not in the meanwhile, I'll actually do that right now. I am going to be visualize heat map. Okay, I am going to push this. Alright, so next time we will start from here. I will do first this little cleanup, try to get everything in order, and then we will start looking into more into those genes, and then try to start figuring out what to do next. So in the meanwhile, I will very soon after this, I will record the recap. I will post everything, so everything's on GitHub, and I am generally available on email and Discord, and I will see you next week. Thank you, everyone.